Hi there, thanks for watching this video. This learning target has to do with simplifying rational expressions. So we should talk about what a rational expression is. A rational expression is any expression that can be written as a fraction. So here are a couple of examples. In fact, we've worked with some of these previously. 14x to the fifth divided by 2x squared is an example of a rational expression. Just something simple like 1 divided by x is an example. It doesn't even have to necessarily have a variable in it. 4 plus 7 divided by 3 times 5 is an example of a rational expression. Of course, we're interested mostly, though, in the ones that do have variables in them in algebra. But we're going to be specifically concerned with ones that have maybe more than one term in the numerator and denominator. So we might work with things like this, x plus 3 divided by 2x squared minus 18 or something like that. Okay, but the expressions we're working with in this learning target can be written as fractions. That's the important part here. Now there's an important piece that goes along with this. We're talking in this video about excluded values. And what we're saying is that since the value of the denominator of a fraction can never be 0, the excluded values of a rational expression are the values that make the denominator equal to 0. So like for a quick example would be that in this rational expression here, x cannot be 0. You know that when we write the equal sign with a slash through it, we're saying not. So x is not equal to 0. It can't be equal to 0 because if I were to put 0 in for x, I would get an impossible value for that rational expression. So essentially we're asking you to find the values that make the denominator equal to 0 if we ask you for the excluded values. So we're going to practice this a little bit. So let's start by looking at this rational expression. It says state the excluded values for the rational expression. And it simply says 1 divided by x plus 3. Now this is a pretty simple and straightforward expression here. But the idea is that I want to figure out what values for x would make the denominator equal to 0. So I'll take the denominator off to the side and I'll either write it out. I'll say if x plus 3 equals 0, what value for x makes that happen? And this one's pretty easy to see what would happen if you subtract 3 from each side. You can see that x is negative 3 is the value we're concerned with. Maybe I shouldn't put a box around that because that's only telling me what the situation here is. And of course I see that if I let x be negative 3, I would get 0 for the denominator. So my excluded value is that x cannot equal negative 3. And you don't need to write this part, but for the first time in the video I want to write this. If x were equal to negative 3, you would get 0. You would get, in fact, you would get 1 divided by 0, which is undefined. So that's worth maybe at least the first time jotting down here. That's why I'm saying that my answer for the excluded values is this, that x cannot be negative 3. Okay. Now we're going to work with a couple of more complicated expressions for the next 2 examples in this video. And I'll say this for you. Whenever the denominator looks like it's something that should be factored, like the trinomials we factored in the last 2 learning targets, do it. Okay? So try factoring the denominator. So I think this is going to help us see what values could make the denominator equal to 0. Our rational expression is 4x divided by x squared minus 3x minus 10. So let me just take off to the side, let me take that denominator and factor it. X squared minus 3x minus 10. Can that factor? This is sum and product factoring, right? I'm looking for 2 numbers with a sum of negative 3 and a product of negative 10. And I think those numbers, sum of negative 3, product of negative 10, is that negative 5 and positive 2? Yeah, I think that works. And a quick check on double distribute x squared minus 5x plus 2x is negative 3x, and then minus 10. Yeah, that works. Good. So here's the thing. What my expression really says, what this thing right here really is, another equivalent form, is to say that it's equal to 4x divided by x minus 5 times x plus 2. And what I really see now is that there are two ways that I could get 0 on bottom. One of them would be if x minus 5 were to equal 0, or another way I could get 0 on bottom were to be if x plus 2 were to equal 0. Because this is a multiplication issue here. So these two things are multiplied together, so if either one of them were to be 0, then the whole denominator would be 0. And I can actually solve each of these equations pretty easily to find x values. This is x equals 5. And this would be, if I subtract 2 from each side, x is negative 2. So when it asks me to state the excluded values, I simply need to say, hey, x can't be these. So my answer is that x cannot be 5, and x cannot be negative 2. That's really where I need to come down on this, because I've shown that either of those values makes the denominator equal to 0. Let's do one more. In this case, we've got 5 divided by the quantity x squared minus 36. And it might help you, since we're going to think about factoring the bottom, to think about the bottom this way. Whether you actually write it out or not, if the middle term is missing, like it is in this case, there's no x term, it's just an x squared term and a number. Writing this out might help you figure out the factoring, because we need a sum of 0 and a product of negative 36. I think some of you guys probably got this. But we're simply saying that I think x plus 6 and x minus 6 works. If I were to do the double distribute move here, the middle terms would drop out, 6x and negative 6x. So we factored the bottom. So this expression here could simply be written as 5 divided by x plus 6 times x minus 6. And again, if this factor is equal to 0, then we're going to get 0 on bottom, and that's bad. Or if this factor is equal to 0, we would get 0 on bottom, and that's bad. So find those bad x values. And again, the good news about this is that these equations that we're writing are really easy to solve. Here I get negative 6, and for this equation I get positive 6. So if those are the values that make the denominator equal to 0, if I want to state the excluded values, I better say that x can't be those. So x can't be negative 6, and x can't be 6. Now this isn't all of this learning target, but it's an important part of it. What we're going to work on in the next video is actually simplifying some of these expressions. Thanks for watching.